into this bright line thinking, that's the problem that you run into. Real quickly, before I can continue down another path, there's also another problem when thinking about p-values, and that is generally what we're trying to do is to conclude something about our hypothesis, I'll call that H, from the data that we have, we'll call that D. So we want to know, we might frame it as what's the probability that our hypothesis is true given the data that we've observed. And we could write that in math notation as P of H given D. But unfortunately, a p-value statement isn't that at all. It's a probability statement about the data, assuming the hypothesis. Remember, several slides ago, I told you that we had to assume that the treatment and the placebo were equal when what we're trying to do is learn whether the treatment is better, whether we're really helping these kidney patients or not. And so even though the probability of D given H looks a little bit like the probability of H given D, they're not the same thing at all. And so oftentimes p-values are misused, like I showed you earlier, because people make this mistake. Now, I mentioned to you at the start of this presentation that the ASA, the American Statistical Association, where I work, released a statement in 2016 about p-values and statistical significance. And I'd like to briefly show you why we did that before saying just a bit more about that statement. So here's a quote. It's been widely felt, probably for 30 years and more, that significance tests are overemphasized and often misused, and that more emphasis should be put on estimation and prediction. Okay, that's what we're saying, but this individual says that it should have been, this has been going on for 30 years and more. And who said it and when was it said? Well, it was said by D.R. Cox, which might not mean anything to many of you, but he is one of the most famous living statisticians. And he wrote that in 1986, which takes 30 years back to 1956. And I'll just own up that that's the year of my birth. So this means that this has been going on my entire lifetime. And so this problem has been acknowledged forever. And I will be happy to send you guys, anybody who wants them, to Paul or Claire. I'll be happy to send these slides. And here's a link to a whole bunch of quotes like this. So if it's been going on my whole lifetime, you know, why did I wait until I was 60 years old to do something like this? Well, start by saying that we didn't declare that anything was new in the statement. What we were trying to argue is that maybe it needed the push of the world's largest statistical organization to finally make some change, because after all this time, nothing else was doing the trick. But we were challenged into action by articles like the one here, odds are it's wrong, and maybe you can see on the screen, science fails to face the shortcomings of statistics. In this article, the author, Tom Siegfried, throws all of statistics under the bus because of problems with p-value and statistical significance. And oh, by the way, he referred to statistics as a mutant form of math, which, you know, kind of gets a guy who's the executive director of the American Statistical Association a little excited. So through a lengthy process, we developed the ASA statement on p-values and statistical significance. We published it in our one of our leading journals, the American Statistician. And I would argue that it's had a large impact. One way to look at that is just raw numbers. It's been viewed as of like yesterday over 435,000 times. Now, I'll stop here for a second and just say, you know, if you think like a statistician, you got to ask yourself, is that a lot? How do we know whether that's a lot or not? I'll show you one way to look at that, a somewhat humorous way, in a moment. It's also been cited over 3,200 times, which again, arguably is a lot, although would take some extra effort to show you that. So I'll start by, this 436,000 views. Is that a lot? Well, not every paper that has my name on it has 436,000 views. This paper is a little less popular than that paper. So that's one way of looking at it. 436,000 is a large number for a look at a statistics paper, but it's pretty small compared to 2.8 billion views of Taylor Swift's Shake It Off video, or 15 million views of scientific studies on John Oliver's Last Week Tonight. That's a show from back in like 2015. But if you haven't seen it, I highly recommend it. It's a very thoughtful look at why we need to think about science and how we explain science to the public and so on. It's Last Week Tonight, it's John Oliver, so it's loaded with the F-bomb, but it's worth watching. So the ASA statement on p-values and statistical significance had 6 principles. I'm just going to highlight one of them today, that scientific conclusions and business or policy decisions should not be based only on whether a p-value passes a specific threshold, like 0.05. We're saying that shouldn't be a reason for you to do anything, is because it passed 0.05 or it didn't pass 0.05. I'll say this in a much more plain way. Bright line thinking is bad for science. And bright line thinking means that you can make a cutoff. You know the difference between right and wrong, positive and negative, whatever. There's a bright line. There's always a bright line, and you can establish that. Well, in a supplement to our statement, Ken Rothman, who's been writing about these things for years, argues that scientists have embraced and even avidly pursued meaningless differences solely because they are statistically significant, and have ignored important effects because they failed to pass the screen of statistical significance. He says, it's a safe bet that people have suffered or died because scientists and editors, regulators, journalists, and others have used significance tests to interpret results and have consequently failed to identify the important course of action. I'm sorry, chop that off on there somehow. So we argue, my colleagues and I, who have written the paper that you'll see a little bit about here in a moment, that it is time to move on and to move past statistical significance. And why do we say that? Well, I showed you through several ways that significance has lost the meaning that it was intended to have. I showed you through those quotes that bright lines lead to bizarre behavior. I pointed out to you that decades of people complaining, people pointing this out, have not changed a thing. And we argue in the editorial that we wrote in March of 2019 that a label of statistical significance doesn't do anything. It doesn't add anything to what's already conveyed in the p-value. And in fact, splitting things into significant or not significant actually makes things worse. And there's one more thing I'd like to mention real quickly. It's something important that's cleverly named the file drawer effect. The file drawer effect argues this way, that people publish their results that are statistically significant, and the rest of those results go into a file drawer, maybe never to be seen again by anybody. Well, for those of you who are a little bit into statistics, you'll catch on to this fast, and the rest of you, I don't think it's too hard. Imagine 100 studies, all of which turn out they don't work. The treatment and the placebo are just the same, they don't work. 100 studies that don't work. But when you use a 0.05 threshold, on the average, you're going to get 5 false positives. You're going to get 5 studies that appear to work when they don't actually. And so that's 5 out of 100, that's only a 5% error rate. But if we publish all 5 of those and we put the rest in the file drawer, the error rate of published articles on that subject is not 5%, it's 100%. Every one of the published articles is something wrong. So My colleagues, Alan Sherm, Nicole Lazar, and I wrote in a special issue of the American Statistician in 2019 that it's time to move to a world beyond p less than 0.05. It's time to say goodbye to statistically significant. And not coincidentally, an article in Nature appeared the same day that our editorial was released. Scientists rise up against statistical significance. Now, I need to be clear here because some people have thought that it isn't. We're not advocating getting rid of p-values. It's statistical significance. It's how p-values are used that we're concerned about. And also let me make clear that I am not in this talk and in that article I wrote speaking for the American Statistical Association. In 2016 on the ASA statement that I was a co-author with, that was a statement of the American Statistical Association. But this article that I'm talking to you about and the issue of the journal that it appeared in it's just research. It's a publication of the ASA. It's not an official statement. Okay, now as we come down the home stretch here, I want to talk to you about why all this matters. Because up to now, I don't blame you if you just think, well, I hope you think that this was interesting, but I hope you're asking, so what? Which, by the way, is a great question to ask. If you ask it with a spirit of curiosity and not with a spirit of cynicism, so what will get you to a lot of places if you're curious. So I want to show you two examples. There are many examples, but you'll see immediately why I picked these two examples. They're highly relevant. So the first one is something called remdesivir. Remdesivir is a treatment that can be given to patients who are seriously ill with COVID-19. So here's what we know, okay? So it's an experimental drug that is being used to treat these patients, and it's being used based on a clinical trial that was released last spring, you see on the screen. And the preliminary results showed that patients who received remdesivir had a 31% faster time to recovery than those who just got a placebo, just, something that looked like they were taking medicine, but they weren't. And specifically, the median time to recovery was 11 days for patients treated with remdesivir, compared with 15 days for those who received the placebo. And if you think about that, you think about being able to get people recovered and out of the system in 4 shorter days, that frees up a lot of space for other people who need to come in because they have COVID-19 or because they have other normal medical conditions that people go to the hospital for. Now, results also suggested that there might be a survival benefit. That is, that the mortality rate remember, these are all people who were very sick when they were getting this drug. The mortality rate was 8% for those who received remdesivir, but 11.6% for those who just received the placebo. And there you see that problematic p-value, one that's a little bit bigger than 0.05. And so that, caused people to think, well, maybe it doesn't improve the survival rate, but maybe it does. So then this happened. It's good news that remdesivir worked. Now, the people in this picture, many of them you probably recognize. To the lower left, that's Dr. Fauci. To his left, that's Dr. Birx. To her left is John Bell Edwards, who is the governor of Louisiana. And to his left is, I don't remember who that is. I'll have to look at my notes later. Now, Dr. Fauci is somebody who I hold in super high regard, and my ears perked up when he, at that little briefing that you saw the picture of, that he mentioned statistical significance multiple times, but he referred to the reduction time in recovery as being highly significant, which is a technical term, but it's about the size of the p-value. It's not about how powerful the drug actually is. He referred to, he used the word trending for that item that was bigger than 0.05. And these are the sorts of things that create various kinds of misunderstandings. So the risk is that people will think that you can just keep taking samples or manipulate the data to have happen what you want to happen, which is not at all what he meant, but it is what comes across. And what's the purpose anyway? So I'm focusing now on that almost significant p-value, that maybe this drug actually reduces the mortality rate for sick people who have it. So we still don't have a confidence interval for this. I don't have time to talk about that, but we know the p-value. And so slapping on a label of significant or not significant doesn't help us here. We see that maybe there's as much as a 4% difference between the treatment and the placebo in terms of the cure or helping people survive. And, that's 12% to 8%. That's a third we're talking about there. That matters. All right, let me show you an even more recent example that appeared last month in the New England Journal of Medicine. And it's about a drug called dexamethasone, which I don't know how many times I'm going to be able to say correctly fast, but dexamethasone was given in 6 milligram doses once daily for up to 10 days versus the just sort of ordinary care. Okay, so again, these are sick people sick with COVID. The primary outcome, that means the thing that they were studying, is 28-day mortality. That is, how many of these people were still alive after this treatment started, 28 days later after the treatment started. And here's the size of the study that was done, okay? Now, lumping everybody together, 22.9% of the people who got the dexamethasone died within 28 days. Remember, they were very sick to begin with, whereas 25.7% of the people who received the placebo, the usual care, died within 28 days. And so the ratio of those things, when adjusted for the age of the patient, is 0.83. If you do 22.9 over 25.7, you won't get 0.83, but there's an adjustment that's made for the age of the participants. And just real quickly, the rate ratio is basically the incident rate of the treatment group to the incident rate of the control group. And so that's the ratio of those things, again, adjusted. Now, if you look at the people who were on mechanical ventilation, okay, then there was a statistically significant reduction. Yes, I chopped off the p-value on here, but it was quite significant. A significantly reduction in the rate of death. So this amounts to, I know rate ratios and all these things don't automatically translate in your head, but roughly we're talking about 1 less death for every 8 patients. And the confidence interval puts that 1 in 8 to somewhere between 1 in 4 and 1 in 15. So that's pretty meaningful. And for those who were receiving oxygen but hadn't progressed to mechanical ventilation, there's also a significant result. It helped, not quite as much as in the other case, but it helped. Actually, it helped more, didn't it? 1 less death for every 3 patients, 111 to 1 in 67. And then the third result was that they said that dexamethasone didn't reduce deaths among those who were receiving no respiratory support at randomization. Okay, they were just not on oxygen or ventilator. And I'll say more about that about 2 slides down. But notice that the 95% confidence interval contains the number 1 inside it, and 1 is no difference between the treatment and the placebo. So they concluded in this article in the New England Journal of Medicine that dexamethasone resulted in lower 28-day mortality among those who are receiving either ventilation or oxygen, but not among the rest. But this is where focusing on significance and p-values really gets you into trouble, because that rate ratio could be somewhere between 0.91, which means it's a little helpful, to 1.55, which means it's a lot, could be a lot dangerous. So just saying that the result didn't reduce deaths among those who were receiving no respiratory support randomization is not enough. We need to acknowledge that this is something we shouldn't give those people. If they aren't needing respiratory support, they're not sick enough to need this drug, and it turns out that it could possibly harm them to take it. Somewhere between, at the risk rate ratio of 0.91, 2 fewer deaths in 100 patients, to 11 more deaths in 100 patients. So what I wish I had time to do is to go over some slides that I have put in here for you to have, if you're interested, what are all the things that we suggest in our editorial and in the special issue that can be done instead. But I'll just point you there to that. And then thank you for listening to me today. And what I think I'll do, Claire and Paul, is stop sharing my screen so I can see people again. Tried to, sorry, I know what went wrong here. So I can see people again and answer questions. There we go.
I just want to start out with, I started recording about halfway through. Is that okay with you?
Sure.
Okay, nice.
So if anybody has a question about anything that I have some chance of answering, feel free to unmute and ask away.
I'll ask a question. Have you seen any progress, I guess, with this p-value escapade you're on here, I guess, with like FDA
so that's,
or anything? Or
yeah, thanks. That's an important question. The FDA is well aware of this and thinking through how they heavily use p-values and 0.05 thresholds to do their business. So they're heavily engaged in thinking of this. The New England Journal of Medicine that I pulled that article from changed its editorial policies as a result of that editorial that we wrote, but not as much as we wanted to. So I'm going to call that half a success, okay? I mentioned when I was talking to someone, Caitlin, were you the anthropologist? Yeah, so that this group of researchers in anthropology and primatology are very much engaged in this and trying to improve their research as a result of this. There have been people who have worked in nursing research to try to improve nursing research through these principles. And we're this close to getting an article published in one of the leading medical journals that we hope would reach a large population of doctors and clinical researchers and so on. But it hasn't been accepted yet. So I would say mixed. People are well aware of it. There's a big discussion out there. So we'll keep pushing. And one of the ways I keep pushing is talking to folks like you. On Monday, I'll be talking to a bunch of scientists at Rice University about the same kind of stuff. So hopefully over time, some things change. My other colleagues are out doing their part as well.
Hey, Ron, this is Mike. I've got a question for you. As myself and Angela and Beth, who are all on this Zoom session, we teach intro statistics. And right now, all of the intro stats books that I find available teach the old-fashioned, here's a hypothesis test, it's yes or no, p-value is too small or too big versus small enough. Do you know of any intro stat books where they've already started to incorporate this idea of a p-value is just one small thing you look at, and down weighting the importance of the p-value?
Mike, I'm reminded of a line from one of the Mission Impossible movies where Tom Cruise says, "Oh no, the problem is much worse than that." The the problem is much worse because even when if you land on this textbook, and I'll get back to answer your question in a minute, you land on this textbook that you like to use, your students then still go off to take business stats or psych stats or whatever they may be, and they show up over there and you haven't told them, in fact, you've told them not to do this, and they get over there and their instructors are telling them to do this. It's a problem. So change in education has to happen at all the levels. Change in journal policies has to happen because there's still many journals who, you don't report a p-value or statistical significance, they're not going to publish your paper. So I have two comments then, Mike, to directly answer your question. I don't know myself whether anybody has made it yet out with a book, but I do know where the people are who know. And I can send you that offline, but like Alan, you know these people or you know their names. Alan Rossman and Beth Chance at Cal Poly probably know who's doing what in regards to that. I know people are working on it because it was the subject of the US COTS meeting last year. In the meanwhile, what do? My best suggestion, and I don't know how great it is, Mike, but my best suggestion is that right now you have to teach it the way it's in the book and the way that the people who are going to receive your students expect it to be taught, because all of us who have ever taught have tried teaching things different than what's in the book, and it makes introductory students absolutely crazy. But what you could do is spend 20 minutes of a lecture pointing to one of these articles from the ASA and saying, even though we do this as a way of simplification, good practice of science challenges you not to just think about whether things are more or less than 0.05, but to think about all the statistics that are involved and what 0.05 means and so on. When you're until this filters into some introductory stats textbooks, it's going to be hard. I can't imagine how to do differently than that, basically.
All right. Well, thank you. That's a good answer.
Yep. Appreciate the question.
So have you looked at research from other countries? Like, is this a global issue that they're having these patterns of these, like, not understanding the p-value or kind of describing it in a way that doesn't make sense?
We've seen a lot of journal articles in English, articles that are written in other languages in other countries. I'm a little, my Arabic is weak, which is to say I have none. Ditto with many other languages. But we hear from people in other countries who have, for example, asked to translate the ASA statement of statistical significance of p-values into their language. So it's been translated into several languages. So Claire, that tells me that the problem is there. If I'm really going to tell you what I care most about in this, it's not even that people misunderstand p-values. That's a problem. It's that somehow over the course of time, the statistical significance has become a conversation killer rather than a conversation starter. That is to say, in both of those examples that I gave you, that something important could be going on with remdesivir related to mortality and with dexamethasone related to possibly it being bad for people who don't need oxygen or mechanical ventilation. But yet there's a tendency in those papers all over the world, as you asked in your question, to see the statistical significance and say, done. I've got something or I don't have something. Way back at the start of the talk, in that paper about helping people with kidney problems, that's exactly what happened. They looked at a whole bunch of things and they paid attention to the things that were statistically significant, and they didn't pay attention to the things that weren't. And when they paid attention to the things that were statistically significant, they didn't pay enough attention to how important what was going on underneath was. So we didn't have time to talk today about something called effect size, but the easy way to understand effect size is simply not just asking how much does this drug help or not. It's asking how much does it help. And if you go all the way back to that slide, I pointed out that there was a wide p-value from 11 milliliters to 183 milliliters. Now, I don't know much about kidney volume, but I have to think that that's a pretty big difference, that only adding 11 milliliters of kidney volume may not matter to a person with kidney problems facing maybe getting dialysis or whatever, but 180 might make a real big difference. And so what I worry about all over the world is that this same idea that we've used the 0.05 or whatever cutoff as something to decide between what's real and not real, what's important and not important, what's effective and not effective. And that's a tool that wasn't really built for that. It's roughly like, me trying to screw in a screw with, the wrong kind of screwdriver. It's just not, it wasn't made to do that. And so trying to do it that way makes your work harder. It makes it more likely that you're going to mess up, or in the case of the simple example I gave, strip the head off the screw, which is really no fun if you're trying to take one out. So appreciate the question, because that's really what we're trying to get to here. It matters. It's the difference between discoveries going undiscovered. It's the difference between things that look like discoveries maybe not being so important after all. So yeah, I have a little passion on this topic, you might say.
So how hard is it to convince, hey, p-value is more different than you think than in statistical convenience? Because people are like, hey, this is a theory, so I'm going with the theory, rather than I don't want the change, because one change will make a significant difference on all the experiment. I rather will stick to the theory rather than understanding there is more to it.
Yeah, that's so important. The change is really difficult. It requires people, it requires us to do things differently. It requires us to think differently. Here's an example that appears in one of those articles in that journal that I pointed to you in my very last slide. The writer, Steve Goodman from Stanford, equates p-values to money. If you think about how money works because we all believe in it. We believe that, if something is worth $100, that this $100 in my hand, this $100 bill or the 520s is a fair trade for that thing that's worth $100. And that system holds together until it doesn't, right? I mean, you all read about countries where they get into hyperinflation and nobody trusts the currency anymore and so on. P-values are science currency. They've been what people have used forever to get their article published or to get their grant funded or to get their policy recommendation approved. And so it's getting people to change the currency that they use. That we're all gonna switch to euros tomorrow or whatever is, you can imagine how well that would go over in a country where we can't even get everybody to agree that masks are a good idea for COVID. So in answer to your question, there actually are people trying to do research on how you talk about this stuff to make it understandable, to make it something that people will embrace, the change that you talked about. But maybe this example would help a little bit. If everybody used p-values and statistical significance the right way, then everything would be fine. People would think differently about it. They would be fine. And so there are a lot of people who say, Ron, what you're recommending is, and I've heard this so many times, you're throwing out the baby with the bathwater. And I don't really know that anybody in the history of the world has accidentally thrown out a baby with the bathwater. But this baby is all grown up and still doesn't know how to bathe itself. I mean, I showed you this has been going on for over 60 years. And so I liken it to this. Suppose there was a car on the market, a great car. It runs for days on a 9-volt battery. Okay, it's just this most amazing eco-friendly car. It looks great. It just everybody wants it. It just has this small problem, and that is that it's hard to drive, and so people wreck in it way more often than they do in other cars. So you say to yourself, all right, let's try to improve the car. So we spend years improving the car, and people are still wrecking. And we say to ourselves, oh, well, the problem isn't the car. The problem is that we need to train people better to drive the car. And so we train people better, or we try to, and they're still wrecking the car. At some point, you'll have to say to yourself, yeah, theoretically, this car would work, but it doesn't. And that's really what the problem with statistical significance is. After even more than 60 years of people understanding that you can't do science this way, people are still doing science this way, and it's not good. So imagining that statisticians are going to fix the problem by just explaining it better is just, I'm just asking you, and after my great explanation, I'm going to hand you the keys to the car and hope you don't wreck. And yeah, that's not a way to do anything. And I know I've kept you way past the amount of time that you allocated for this. I have nowhere to go, but if I need to let you go, I do want to make sure before I do to tell you that in my unbiased opinion, you are at a fabulous university. I've had a lot of experiences in life, and everything that I've ever done, I've never felt like I couldn't do something that needed to be done because my Washburn education was inadequate. No, quite the opposite. And the math department was an extremely nurturing place to me. I ended up in graduate school because I'd never thought about graduate school, but math professors helped me think about going to graduate school, and that made all the difference in my life. So I'm happy for you that you are Washburn students, and I'm grateful to you for giving me the chance to talk about a subject that I really care about with you today.
Thank you for meeting with us. You'll have to give a thank you to Dr. Cook. She's the one who suggested your name to me. And once I looked you up, I was like, oh my gosh, yes, he's the one for our first meeting. So thank you.
Yeah, Dr. Cook is famous for her bad judgment. I almost left, Mike, without leaving you a dad joke to take home to your family. Okay?
I need
My wife and I were talking the other day about the fact that due to all that's going on in the world, we can't take a vacation this year. And unfortunately, our suitcases overheard us, and now I'm dealing with a lot of emotional baggage. Yeah, Angela, I apologize. Take care, everybody.
Thank you,
Thanks,
Ron.
Ron.
See
Thank
ya.
you so much.
Bye-bye.
Bye.